So one of the things I'm considering for my Altair 8800 project while I'm at VCF is to use a linear power supply rather than digital switchers, just because it's a lot more period accurate. Sitting here is a linear power supply that I built probably 15 years ago, maybe longer, just out of junk from my junk box, to provide +8 and ±16. This was used to power up a little 8-slot troubleshooting kind of setup I had for S100 stuff. Did a lot of prototyping and playing with it. Don't really know what kind of current this system, this layout as done, can provide. There's two 24,000 microfarad 50-volt caps here, so there's about 48,000 microvolts. Use 48,000 microfarads, 48,000 microfarads. Say it correctly. A filtering on the +8 line, and there's just some banks of, what are these, like 2,200 microfarads. So there's a lot of overkill here for the plus and minus 16. There's bleeder resistors on everything, and a big heavy bleeder resistor up here, just so that the voltages bleed off. I've got my constant current unit back here that just had an issue, and I had some magic blue smoke erupt from it. Not quite sure what I did, but it still appears to be working well enough for the experiment here. I don't think it's holding constant current as correctly as it should be. I'll have to troubleshoot that. I've got a meter here to measure current, so this is going to be current drawn amps. I've got a meter here in the middle to measure the voltage across the filter caps, and I've got a meter here in AC mode to measure ripple across the filter caps, and we'll see what we get. So let me bring the power supply up, and currently it's outputting 10.58 volts. There's 40 milliamps, if I can trust that being drawn, and basically no ripple. And let's get in here. Let me try to slide this back out of the way, or my arms out of the way, where hopefully we can see the screens, and we'll start to bring the current up. And this is what I was talking about, this kind of weird dance it does at low current. Let's push it up towards an amp. There's a quarter amp. Yeah, I've definitely done something that's hurt the unit. It'll stabilize here at higher currents. Not exactly sure what happened when it erupted the magic smoke. Well, we've done all that to get to half an amp. Doesn't look to be a whole lot of ripple. The voltage is still holding constant about 10 volts, which is high, but that will load down as we actually get the current significantly up. Getting a battery warning on a meter. Come on, there we go. There's about 1 amp. Voltage has dropped down to 9.8 volts. The idea here is, can this thing sustain, this linear supply, provide enough current? Wow, this poor constant current load, I really screwed something up. There's about 2 amps. The voltage has dropped down to 9.3 volts. On 4 volts, we're set to AC. With 2 amp load, I'd expect to start to see some ripple here, so I'm actually surprised that I'm not seeing ripple. The question becomes, is the meter capable of seeing what I want to see? I should be able to flip you over to AC and look at ripple there as well. And it's going to settle down. Not sure I trust this. Well, let's keep pushing the current up. It's weird, it does that weird peak up and down. So about 3 amps, the voltage has come down to 8.9 volts. So remember, the higher the voltage going to the 7805 regulators, the more heat they need to dissipate to produce a constant 5 volt, because the delta between 5 volts and the input voltage is dissipated as heat. So, with current loading bringing the voltage down, that's not necessarily a bad thing. I'm sure the system is drawing more than 3 amps, though I don't know that. I've got to measure the actual current draw on the computer itself. This is getting us up to around 4 amps. Voltage is down to 8.5 volts. I really don't trust that ripple measurement. May need to dig a scope out, and actually watch the ripple rather than try to measure it in AC voltage mode here. And I'm really looking to see how hard I can push this to either get magic smoke, which I don't want to do. So there's 5 amps. We're still at 8 volts. That's plenty of overhead for the 5 volt regulators. Again, that's not bad. Let's push it harder. The diode bridges, I believe, were... I don't seem to be able to push it any harder than that. So that's 5.29 amps. Yeah, it really doesn't want to be pushed any harder than that. So I think we are at the maximum load I can provide, which again is kind of surprising. You can see the voltage hovering around 8. I'd like to push this to a higher current than that, although at this point, you know, delivering 5 amps, everything seems reasonable. Yeah, I'm going to have to fire up a scope to look at that ripple. Is this scope plugged in? And no, it's not. You know, the plus and minus 16, I'm not too worried about. The current draw is not very heavy in the system. This transformer really wasn't meant for S100 use. It's a little high on the output for the 8 volt, 7.5 volt rail. But again, it come out of a junk box and recycle. And the voltages were close enough. Like I say, probably 15 years ago I built it. So, let's see here. Can I add some load onto this? Oh, that's dusty. 5 volts divide 47 ohms is only 106 milliamps. Let's do 5 volts divide 5 ohms should be 1 amp. Let me go see if I've got another load floating around here. I should have if I can spot it. So what I'm going to do is I'm going to substitute in this load box, which goes from 0.1 to 99 ohms. This is a high current. Set the resistors via the rotary switches, and we'll try this load instead and see what we get. So I'll be back in a second. So I've substituted in another current load here. We just looked at it a second ago. This came up surplus at some point. It had been heavily modified. I'm not going to say rebuild it, but I cleaned up the modifications. And it's supposed to be a 1 mega ohm high power resistant substitutor, but it had been wired inside to be much lower than that. Like I say, what I made was 0.1 to 99.9 ohms. And I believe that's correct. We've got 10 ohm steps, 1 ohm steps, and 0.01 ohm steps. They are very large power resistors on heat sinks inside. Same setup, current, voltage, attempt to measure ripple, although I'm not convinced that's working. And let's go ahead and bring it up. So we are at 100 ohms. Wonderful. Oh, oops. I'm sure you can't see this clear. 5 volts divide 100 ohms should be 50 milliamps. And why is that measuring closer to 100? That's curious. But let's increase the load. See if we can get this to really drive up hard. We can't even approach an amp here. So that's got us to an amp. And really it's going to be stepping down from here to bring that up more significantly. There's an amp. Hopefully I'm not going to see magic smoke happen here. 2.7 amps. We're up at, wow, this, okay. 3.8. I expect the next step to really jump that up. But we can really influence it over here. 4.6 amps. 4.8. This will get us slightly over 5 amps. Voltage is holding at 8.18 volts, which is good. 5.3 amps. We're actually seeing some ripple, although 87 millivolts seems really small ripple to me. See, we're measuring more like 156 millivolts potential ripple over there, so I don't think I'm trusting this meter. Let's push it again. 5.62 amps. Let's bring this all the way back up to the max resistance and take you down to 0. There's 6.4 amps. And the voltage is starting to get down to the point where it would be about 2.6 volts overhead here for a voltage regulator. But again, I'm pushing this pretty hard. Don't want to see magic smoke. 6.7 amps. 7.4 amps. And really, at this point, I would become concerned that the regulators would start to get into trouble. 8 amps. Almost 9. And that's only 2 volt overheads for the regulators, which may or may not be a problem. It most likely could be. And I don't believe the ripple's that small. 228 millivolts. I just don't believe the ripple's that small. I think the setup's lying to me. But I feel like this power supply here, basically as is on the, really what becomes the 8 volt rail on the bus, is probably good for, I feel like I could trust it at 7 amps. Like I say, I don't know what the current S100 setup I've got downstairs measures. We're going to have to go put the ammeter in series with it and take a look at the actual draw of the system. I don't even have a guess at this point. If it's an amp per card, I'm drawing approximately 10 amps down there. I don't think it's going to be that high. The memory cards certainly are going to draw a fair amount of current. Not feeling any heat. So 5 volts divided by 8 ohms is 0.625 ohms. It's essentially resistance in here, and we should be set at 0.01 steps. These tags were wrong when I rebuilt this thing. It should be 0.6 ohms, so that seems to track. And approaching 9 amps. If I can believe this, 223 millivolts ripple, which means that's potentially dipping as low as 6.9 volts, assuming this ripple centered around the 7 volts there. I can't really say that. I could actually measure that with this meter in the AC-DC mode. I didn't do that. Again, I'm not trusting that meter at the moment. me pull another meter out here. If I can get the paper tags off the front of it. It was from another bench setup, using multiple meter bench setup. Let's just go ahead and disconnect that. We don't want to short it. Off. Go to AC volts, 2 volts. Maybe the oldest digital meter I own. We want to go positive to positive, negative to negative. It's measured about 220 millivolts again, so I guess the two are consistent with each other. You know, the hum of the transformer hasn't really changed, so I'm not loading the transformer heavily. And that was my biggest concern. You know, I'm not really good at looking at a physical transformer and saying, oh, at 10 volts, that's probably good for blah, blah, blah. Can you see the transformer? You can kind of see it down in here. Rather than try to move the camera. Oops, those are just hanging there. Try to move that more into the shot. Transformer's sitting back here. Bring it up. It's 8.8 amps. That's probably more than enough for what I want to do. You know, these capacitors haven't let go of the magic blue smoke, so potentially reuse them. Although I've got some other large electrolytic, computer grade electrolytics here. I don't think I have clamps to mount those in a chassis. I'm gonna have to give this some thought. I bought a reproduction of the original power supply board that could be used for part of this. It'd be nice to at least use that for this part of the circuit here, and I think these are actually pretty good sized capacitors. Who's beeping? Let's see what it does being switched off and on in current mode. I think I'm going to let this cook for a few minutes. I don't feel any real heat being dissipated, but like I said, huge bank of power resistors in there. Nice little box. It was a friend picked it up. It was just a few dollars surplus someplace, and like I say, I rebuilt it. There was a huge hole punched in here with a big cable bundle that came out, and I was going to return it to her, and she said, no, go ahead and hold on to it. She didn't have room or use for it, so found a use for it. Anyhow, I will wrap this piece up here, and we'll continue to look at this analog power supply build in a future video.